Well, welcome to the 4.4 video lesson. I know you're super heartbroken that I'm not there, but let's carry on with this. We're looking at prime factorization. You should have had a chance to go through, do your warm-up. You've got the answer key. Please make sure you're going through, you're checking your answers so that you can see where you're at. I'm just going to quickly summarize some of these here. Prime factors, just remind you your prime numbers. They are not 1, starting at 2. Then we got 3. Then we got no other evens. We got 5. Then we got 7. Nope, not 9. That divides by 3. But 11, 13. Oops, skip over. 15. We got 17. Then we got 19. Next one's 23, and on and on and on. You can use your Christmas tree diagram if you want. Do the Christmas tree breakdown, or you can do the other that I showed you. Take it on the side. 144 divided by 2 gives us 72. Divide that by 2 gives us 36. Divide that by 2 gives us 18. 2 again goes down to 9. Now we're out of 2s, so let's move to 3 and divide by 3 again. So we've got now 2 times 2 times 2 times 2 times 3 times 3. 2 times 2 times 2 times 2 times 3 times 3. Combine them, so let's simplify it up. That's 2 to the 4 times 3 squared. Okay, go on to look at evaluate. Express your answers to decimal places. Okay, whenever you're doing your dividing, there's always brackets around every numerator and always brackets around every denominator. This is just punching it into your calculator. So make sure that you do your numerator first. 12.3 minus 7.8 gives us 4.2 divided by that 0.14. Now we can divide those. Punch into your calculator. You get, ooh, look at that, a whopping 30. Okay, same as all these other ones, just punching them straight into your calculator. Repeated multiplication, I'll just do this first one, make sure you got that. 3 cubed, actually I'll do the second one, 2 to the 5. That means there's 5 2's multiplied together. 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5 of them. And then we can multiply them straight up like that, or use your calculator button. 2 to the 5, evaluated, gives us 32. Now this next part here, this is really important for the lesson here. We've got the square root of 5 squared. Well, 5 squared, that's 25. And if we did the square root of 25, oh, look at that. That is 5. Then we've got 9 squared. That's 81. Square root of 81, that's 9. Wait a minute, we're getting right back to that number in there. Oh yeah, that's because a square root and a squaring cancel each other off. So the square and square root cancel each other off. We're left with that which was underneath the square root sign. Now if I did the cube root of 8 cubed, well, let's do the cube root first. Cube root of 8, that's 2. 2 cubed, that's 8. Oh, hey, this works as well. I can just cancel those off. The cubed and the cube root cancel each other off, and we just get left with the 8. So when we go to the 5th root and 5th cancel each other off, we're just going to get 2. Alright, and now flipping the page over to 234, we're getting into the meat of it. Let's quickly look at our number systems again that you've learned. So we've got, starting off with our natural numbers. These are our counting numbers, 1, 2, 3, 4, so on. Then we move into the whole numbers. These are all of our 1, 2, 3, 4s, but also an extra 0. That's the only extra number that we add when we move from the natural number to the whole number system. Easy way to remember it. Whole has an O in it. Kind of remember that, it's the 0 there. Then the next set of numbers that we have are the integers. These are the 0, 1, 2, 3, 4. So it's all the whole numbers and their opposites, so your negatives. But there's no decimals or fractions yet. That's in the rational numbers. Remind you what I told you before. Rational numbers, that's just a fancy word for fractions. So these are things like 3/5 or decimals that terminate, end, or repeat, because those can be put into fractions. So 0.2, that's like 2/10. Square root of 9, hey, that's just 3. And that falls into our rational numbers. Then we walk in what the whole point of the lesson here is irrational. Those that are not rational numbers. So those are things that cannot be put into a fraction. They are not terminating, which is ending, or repeating decimals. So these ones are just, they're decimals that go on forever. Without repeating. That's our irrational number. Hey, well, a radical, that's a fancy way to say these roots, the square roots and stuff. They have 3 different parts. We've got a root symbol, an index, and a radicand. Let's see what that all means together. I'll use this example here. We've got our root symbol. Then we've got an index. Let's say it's a cube root of the radicand, 64. Okay, so all that together is our radical. So this here, this part's our radicand. This part here is our index. One thing that you do need to remember, though, is when we do a square root, there's a tiny little hidden 2 there that we don't show. So if it's a square root, so for square root, we don't need to write, don't need to write the index. And that index was 2. Alright, let's let the fun begin with working example number 1. Converting from a power to a radical. Hey, in 4.3 we did exponents that were fractions. We're going to look at them again from this point of view. But a neat thing is that when we have fraction exponents, we're actually talking about radicals. So we've got the denominator. I'll write it over here. So the denominator of the fraction in the exponent. So the denominator of the fraction in the exponent is the index of the radical. Meaning, when we've got 64 to the 1/2, that 2 is actually what's going to do the moving. That becomes the index of 2 here. And again, we don't have to show the index of 2. So if we've got 16 to the 3/4, that 4 is going to do the moving in front of the radical. That 4 is going to become the index, so 4th root of 16 to the 3. Then we've got 8x squared to the 1/3. Again, that denominator does the moving. The numerator just stays where it was. So that denominator becomes the cube root of 8x squared. Alright, this is where you're going to have your turn to work those through, to try these out. So I want you to pause the video at this point, complete it, and complete your turn. you've got the answer keys. I want you to go through them and then check on the answer key before you start the video again to go to the next working example. Alright, pause now. And welcome back. We're looking at working example number 2. Hopefully that your turn for the first one went well. Again, if you are having a little bit of trouble with it, rewind the video. Go back through. What did we talk about before that? Go through it again and try the your turn. Okay, working example number 2. We're going to go the other direction. If we have an index, that becomes the denominator. Index becomes the denominator of the exponent. Let's look at B. We've got our index of 4. That becomes the denominator. So we've got 1 over 4 on the outside. We already had a 3 there. Let's make it into our fraction 3 over 1, just so that we can easily multiply the fractions. 3 over 1 times 1 over 4. 3 times 1 is 3. 1 times 4 is 4. So we got 4 to the 3/4, or if you take a decimal, 0.75. Looking at this one, again, we got an index. The index does the moving. It becomes the denominator. The numerator just stays. What was ever there stays as the numerator. And we get 4/5. Ooh, checking out D. Ooh, fancy here. That's just a 2 there. It's a good idea to throw it down when you got a square root and you have to move it. Put the index of 2 right there and do the moving. Becomes 1/2. What was here? Ah, it was s cubed that was already sitting there. Make it over 1. So you get 3 over 1. Multiply exponent times 1/2. 3 times 1 gives us 3. 1 times 2 gives us 2. So we got 3 over 2 there. Over to page 236. Your turn again. Pause the video. Check your answers in the answer key. Make sure you've got this concept before moving on. Alright, now that you've gone through the your turn, let's check out working example number 3. If you have to go back, rewind the video, look at it again, go ahead and do that. Alright, working example 3. We're converting mixed radicals into entire radicals. Huh? Got to figure out what those two mean. So mixed radical. Mixed radical has some coefficient in front and then a radical part. So it has 2 parts. Could be a fraction, could be anything in front, and the radical could have an index with it. The index goes with that radical. This is our mixed radical. Kind of like a mixed fraction. An entire radical, that's when we take everything inside the house and we've got just a 1 out in front. And the radicand we have there. Again, we could have just a 1 out in front. Again, that index goes with the whole radical part. And there could be an exponent inside. That's fine. This is an entire radical when we just have a coefficient part of 1. Okay, let's look at what we've got. A couple different ways of doing these ones. But whenever we have our 5 out in front, to take it inside the house, because our index is 2, we're going to do the opposite of square rooting. To take it in, we're going to square that 5 and bring it in. So we get 5 squared. So bring her in there. 5 squared, oh, that's 25. 25 times 11, 275. Now we've got our entire radical. Again, you got all your instructions on the side there that you can read as you're going through. Checking out the next one. Ooh, what happens if we got a cube root? We got to do the opposite. To take the 2 inside the house, we do the opposite. If it's a cube root, we're going to cube that 2 to bring it in. 2 cubed, that's 8. 8 times the 5, we got the cube root of 40. Over on page 237 there, we've got part C. So when we've got a decimal on the outside, it's a cube root. Do the exact same thing. Take that, do the opposite of cube rooting, that's cubing to take it inside. 1.5 cubed is 3.375. Multiply that by the 6 that's already underneath there. We've got the cube root of 20.25. Or what happens if it was a fraction out here? What if it was 3 halves? Well, we're going to take that inside exactly the same. But when we've got a fraction and we're cubing it, what we're really doing is we're doing this. Give them each their own. We got 3 cubed over 2 cubed. 3 cubed, 3 times 3 times 3, that's 27. 2 cubed, 2 times 2 times 2, that's 8. Now we've got fractions. Change this 6 to 6 over 1, make it easier on yourself. Then we multiply numerator times numerator, denominator times denominator, 27 times 6. That's 162, 8 times 1, oh, that's still 8. And reduce that fraction. What can I divide them both by? Oh yeah, 2. Let's divide them both by 2. 162 divided by 2 gives me 81. 8 divided by 2 gives me 4. Now I got the cube root of 81 over 4. Oh, we're right back into another your turn. That means pause that video. Pause it, go through, check your answers on your answer key. Make sure you're getting this right. If not, go back, rewatch. See what you're missing. Alright, now we get into a key part here. Work in the other direction, going from an entire to a mixed. This is a little bit trickier than the other way. So, I'm going to do it slightly different than the way that they're doing it here. So, we got square root of 27. Let's take it on the side. Let's do that prime factoring. That's why we needed to make sure that we could do that. This method works all the time. So 27, let's divide it by the 3, takes us down to the 9 divided by the 3, gives us our 3, divided by 3 gives us our 1. What we've got here is the square root of 27 is 3 times 3 times 3. We're looking at a square root of 3 times 3 times 3. We want to get them into groups of 2. If it's a square root, groups of 2. That means we've got the square root of 3 squared times, oh, all lonesome there. He doesn't have a partner. Squaring and square rooting, they cancel each other off, just like we did in that warm-up part. Boom, boom. We get left with 3. Oh, and this guy's got to stay inside the house. 3 root 3. Now we've taken it down to a mixed radical from an entire. Okay, let's try what happens with 50. Take the 50 on the side. Prime factoring. Divides by 2 gives us 25. Divide, can't do 2, can't do 3. Oh, 5. Gives us 5. And 5 down to 1. Take that back. We've now got square root of 5 times 5 times 2. I'm just going to put them in that order because, again, I'm looking for that group of 2. Mom says, hey, you can go outside the house and play if you take yourself with a partner. So these guys, they get to come out. That's really meaning square root of 5 squared times the square root of all lonesome 2 there. Square and square rooting cancel each other off. We get left with 5 root 2. Alright, 48. Okay, let's take some room down over here. I'm out of room up there. Square root of 48. Well, let's take our 48 on the side. break her down. 2 gives us 24, then 2 gives us 12, 2 gives us 6, 2 gives us 3, and 3 gives us 1. So I'll bring that in there. We got the square root of 2 times 2 times 2 times 2 times 3. Square root tells us groups of 2. That's what Mom said. Gotta go in group of 2. So there's a group of 2 of the same. There's a group of 2 of the same. Lonesome guy here stays inside the house. So now we got the square root of 2 squared, and the square root of 2 squared, and the square root of the 3. Square rooting and squaring cancel each other off. We're left with 2 times the square root of 3. Or in other words, 4 root 3. That's done. Alright, and then on D, cube root of 54. Do the exact same thing. Take your 54 on the side. Do your prime factoring. Divides by 2 gives us 27. Divides by 3 now gives us 9. Divide by 3 gives us 3. Divide by 3 gives us 1. Bring that back in. So we've got the cube root this time of the 3 times the 3 times the 3 times the 2. Mom says now, hey, you go outside the house, you need a group of 3 that are the same. There's 3 of them that are the same. Meaning we've got the cube root of 3 cubed. Do not confuse this index with a coefficient. That's the regular size. This is a bit smaller than, it's really the same size as an exponent. So we got cube root of 3 cubed multiplied by the cube root of just lonesome 2 there. Cubing and cube rooting cancel each other off. So we finish off with 3 and a cube root of 2. That's the mixed radical. Okay, let's try E, 4th root. Take your 80 on the side and break her down. Divide by 2 gives us 40. Divide by 2 gives us 20. Divide by 2 gives us 10. Divided by 2 gives us 5. And divide by 5 gives us 1. We are looking for groups of 4. So we've got the 4th root of 2 times 2 times 2 times 2 times 5. Group of 4 right there. And we've got the 4th root of 2 to the 4 times the 4th root of 5. 4th root and 4th thing cancel it off. Leaves us with 2. 4th root of 5. Yeah, I know it's a little bit tricky, for sure. I'm going to do a what if before you get to your turn. What if? What if this was the cube root of 80? Not the 4th root, but the cube root of 80. So I'm changing the question slightly. In this case, we would have had the exact same thing. The cube root of 2 times 2 times 2 times 2 times 5. Why I do this is because now it's get group of 3 that are the same. There's a group of 3. Cube root of 2 cubed times. Then we got these lonesome 2 and a 5. They're going to stay inside the cube root house. Cubing and cube rooting cancel off. We're going to get 2. And what to do with the 2 and the 5? Multiply them back together. Root 10. All right, it's your turn. Okay, so pause again. Do your turn, your 3 there, and then pick back up into the video. So pretty good chance that you may need to replay the last working example number 4. I know that's a tricky concept. You're going to have to go over it, hear it again a little bit. So don't worry about going back, listening it again, checking it out. And number 5. Now we're going to order them. We're going to put in order from, be real careful. Half the questions are going to say least to greatest. Half are going to say greatest to least. So you're doing least to greatest, small to larger. Okay, small to large. Well, there's a couple different ways of doing these. First one, because they're all square roots, we can change them all to an entire radical. This only works because they're all square roots. So we'll write that since all are square roots. We can do this one. Okay. Well, let's take them back to that entire radical. We did that just a bit ago. The 2 is going inside, doing the opposite of the square root. We're going to square them. Okay, and 2 squared, that gives us 4. Or if you'd rather, you can go, just take it as multiply it by itself. 2 times the 2 to go inside. 4 times the 18, that's 72. Good, got her in there. Oh, squared 8, that's nice, that one's done, that's already root 8. 3, taking the 3 inside, square it. 3 squared, that's 9 times the 2, 9 times 2, square root of 18. And then we get root 32. Done. Now, got to go from smallest to largest. Root 8, that's our smallest number. Then we go through, square root of 18 is the next one. And, 32. And finally, that one's 4th. So we're going to order those. First one, second one, square root of 18. Third one, root 32. Fourth one, root 72. But wait a minute, those weren't the original questions. It's better to take it back to what was the original numbers in the question. Right from up here. So we've got root 8. The square root of 18 was actually 3 root 2. Root 32, and then the root 72 is actually 2 root 18. That's the answer you would give. Or we could go through and do approximate values. Just means take it to a decimal. Well, plug her into your calculator. You can go the square root of 18 multiplied by 2. Get you this number. Take it to 2 decimal places just so we can round it. Or you could just plug straight into your calculator 2 root 18, enter, and it will give you this number right off the bat. Okay, square root of 8. Plug that into your calculator, 2.828427125. ... That goes on and on and on forever. We'll round that 2.83. 3 root 2, that's 3 times square root of 2, 1.41421, ... Go a little bit past, if you're doing 2 decimal places, just go a little bit past that, and then we can round it multiply by 3, 4.2426, ... Don't round it, don't round it until the end. Last step, now you round 4.24. Square root of 32, 5.65685, ... Round it. Okay, the 6 can round that 5 up, 5.66. We can look at where they are on the number line. If you had to put them on a number line, you'd stick them in there. This is 2 point something, so 2 point close to 3. 3 root 2, that was 4.24. So which one was first? This was first. This one was second. This one was third. This one was fourth. And then we plug them into the number line. And 3 root 2, root 32. Go back to the originals. Root 32 and 2 root 18. Hope this one was 4. Whoop, nope, 5.66 on the number line. So put those in there, and we got them. Alright, trying your turn, lucky you. You're going to use both methods. Try to do it by going to entire radical, and then also do it by taking it to a decimal. Again, go through, work it, and check your answers. And finally, we've got our working example number 6. Oh, everybody's favorite. The nice written questions. Let's finish off with a goodie. The CB mine is located in Leonel Lake, Saskatchewan. In 2007, the average volume of gold produced in one day was 180 cubic centimeters. Suppose 5 days of gold production is formed into a cube. What's the approximate length of the edge? And whenever you do these word questions and they tell you what to round to, make a note of that right at the beginning so that when you get to the end, you can look back and say, oh, it's the nearest tenth. That is meaning 10 has 1 0. That's 1 decimal place. Alright. So, let's first of all find what's the volume of gold produced in those 5 days. Well, if one day was 180, that means 5 days is 5 times that amount, which gives us, my right page, where I wrote it down, there we go, 900 centimeters cubed. Okay, so start with your formula. If we're looking for what the edge length is, we've got a cube, which is E by E by E. Your length, your width, and your height are all the same. So, start with your formula. V equals E cubed. Fill in what you know. We know that the volume was 900. So let's substitute that in for the volume. We want to figure out the E, so we do the opposite of cubing. Cube root both sides. Cubing and cube rooting cancel off. We get just left with the E on this side. Now we've got to plug it into our calculator. Cube root of 900. Put that in your calculator. Comes out to 9.6548 ... Or there's another way you could have done this. Instead of cube rooting both sides, the opposite could have also been raise it to the power of 1/3. That's opposite as well. They really mean the same thing. It's just what buttons you punch into your calculator. 3 times 1/3, that gives us 1. So we got E again. 900 to the 1/3, punch into your calculator. 900 to the brackets, 1 divided by 3, and your bracket. You got to make sure you put brackets here. Again, you get the same answer. Look at that. You better. It's the same question. And round it to the nearest. Ooh, what did it tell us again? To the nearest tenth, 1 decimal place. That 5's going to round the 6 up, so 9.7. Ooh, centimeters. Make sure we got the units on that as well. All right, finishing off, your turn. Ooh, looks super fun. Look at that. You got some more gold. Okay, different amount. Go through, do the same thing. Follow the example we just did. Make sure you've paused and you've gone through your turn. All right, coming back into this. Finishing off, your key ideas. Read through this whole page here. It re-summarizes everything we just talked about, okay, all the way through. Good luck with that. You are going to get into your questions and you check your understanding next page, and you can do all the questions all the way through. You got the rest of the time to work. All right. Have a good one and see you in class.